Hi everyone, this is Ken. Today I'd like to talk to you about gcoap. I'll give you an idea of what it is, talk about its current state of development. There's also a demo of a sensor data collection application that sends the data to a server. And then finally I'll talk about the next steps in gcoap's development roadmap. So gcoap is a RIOT-specific implementation of the CoAP messaging protocol. And so what RIOT-specific means is that it uses its internal structures like the SOC networking module, and it also uses RIOT's internal messaging and event loop, which provides for an asynchronous model for application development. gcoap also supports multiple threads in the sense that you may have worked with a web server in the past that supports multiple applications. But in addition to handling server-side responses, gcoap also manages the client side as well, which is important for confirmable messaging for managing retries. gcoap uses a static memory model, and then it also includes a number of macros that allow you to fine-tune how much memory you want to allocate for different purposes. I felt that the CoAP protocol was important enough that RIOT should have its own implementation of that so that we could tailor it as we best see fit, as opposed to having to rely on a third-party library which might have constraints that would limit what we could do with it. And also, since it is meant for RIOT, gcoap is licensed under the LGPL. So since RIOT is the friendly operating system for the IoT, gcoap is also, I've tried to make the API accessible and well documented. So let me give you an example of that. I'll bring up the source documentation for gcoap. And so what you see here is the portion of it that's used for a server creating a response. And what I'd like to draw your attention to here just is the basic 3 steps that you can use to generate a response. So first there's the gcoap resp init, which just initializes the response with certain parameters. Then you would actually write out the payload to a certain location as specified in this CoAP packet data structure. And then finally you send a gcoap, or you call the gcoap finish function, which completes writing the payload. And then since it is a response, you just have to return the result. And since this is happening, it's in a callback, then gcoap will handle actually sending the message back to the client. So let's go back to the slides now, and also just to let you know, just the slides themselves are also available at the URL that you see here on this page. So gcoap is built on top of another CoAP library, actually written by RIOT's own Caspar Schleiser. It's meant to be a minimal application, nanoCoAP. And nanoCoAP is really, it's a library for functionality, which is mostly how gcoap uses it, as a lower level API. But then nanoCoAP also has application layer functions. So there's one for a client to be able to collect a resource, and then there's also server-side handling to generate responses. nanoCoAP is also designed to run on both Linux and on RIOT. gcoap uses nanoCoAP mostly as a lower level API, so it uses the library side of things, and it's really been great for gcoap's development because it's I haven't had to worry about the lower level API. That's just sort of handled for me. And also nanoCoAP has some really nice abstractions in the way that it's organized its structures and that sort of thing that works really well. So as I was saying, gcoap uses nanoCoAP's lower level API, which includes the constants, and then also the utility functions. And you can see down below at the URL the source code if you'd like to dig in and learn more. So what works today with gcoap? Well, I started out with non-confirmable messaging from the server and client side, and then this data collection aspect was really important to me, so I implemented the observe extension to CoAP on the server side, that is, which is where most of the functionality is. So what's going on currently with gcoap is implementation of confirmable messaging, and you can kind of see that in the next couple of bullets. So the important thing is that you are able to send a piggyback ACK. That's the basic where you send the payload, where the server sends the payload back with the ACK, but then also on the client side it supports retries. So actually this has not been merged into the RIOT master branch yet, but it is there is a PR for it, 7337, if you'd like to take a look and start working with it. Also, the confirmable aspect has been extended to notifications as well, and that's implemented in PR number 7548, and that's actually the last PR that I've published related to the confirmable messaging stuff. I'll talk in a minute, or actually after the demo, with what's going to come next with the confirmable messaging stuff. And then also in terms of gcoap, Hauke Peterson has taken an interest in this as well, and he's created an implementation of the core resource directory RFC, and you can see there the PR where that's available as well. So next I'd like to start talking about the this data collection demo that I've put together. So this includes basically three elements. There's a RIOT node, which is going to be using the observe mechanism to be able to send sensor readings to the server. There's a separate Python application that I created that runs the server side of things, and then in between there is a RIOT border router that's acting as the go-between between the wireless network and the wired network. And here in the picture you can see the RIOT node, which is just a SAMR21 Explained Pro dev board, and then it has hooked up to it a temperature sensor using the and then it uses the SOL API for being able to collect the sensor readings. And to give you an idea of the flow of messaging, what happens here is you can see the RIOT node. To begin with, it needs to notify the server that it exists. And so it sends this confirmable post to the server, this registration to it, and then it expects to receive an ACK back, which lets it know that the server has recognized it, and so that it knows that it's gotten past that first level. Then what happens is that the server says, oh, I've been sort of expecting to hear from this node, and I want to know about its data readings. And so it sends a temp request, an observe request, back to the RIOT node, and that stimulates the RIOT node to immediately send a response with the payload, but then also it periodically sends the payload in further observe notification messages. And you can see below this example application, a link for it down here. So what's going to happen next is that I actually recorded the demo separately, and so you'll see that magically I'm going to change from a green shirt, or I'm sorry, from an orange shirt into my other green shirt, and then I'll be back to finish up with the rest of the presentation. Hi everyone, this is Ken. Today I'd like to give you a demo of gcoap's observe messaging capability, and we'll do that through an application to collect temperature readings. So let's go over here and take a look at the shell windows. Over here on the left we have one for the wireless node that has a temperature sensor connected to it, and I'll be starting that one up in just a minute. In the middle here we have the border router, and you can see this one has two interfaces. There's the wireless interface here with that one network, and then there is a SLIP interface with this network. You can see that I've started the RPL routing on the wireless interface. And then down below we have the server application that's going to be collecting the data readings from the wireless node. So let's go ahead and power up the temperature collection node. And it takes a minute or two for it to get started up. I'll just keep trying to start up the shell here until we get through. Okay, you can see we're through here. You can see it sent this hello message, so the wireless node is registering with the data server, which I'm calling data head over here. And you can see over here that the data server has received this DHLO message, which is short for hello. And so then the next thing that happens is that the server sends an observe request back over to the wireless node, and you can see the wireless node has already started collecting temperature readings. And so let's see, there's the first data collection response that's come over with the value of 0, and now you can see the second one here, which is a temperature of 24 degrees Celsius. So I know that happened kind of quickly. Let's go over here to Wireshark, which is recording the whole thing. So you can see here in the first communication, this is the wireless interface sending a message over to the data server, and you can see here it's confirmable. So we're going to send this first confirmable message with the hello message, and then we'll see that the data server sends the acknowledgement back, and then the next thing we can see is that the data server, now that it's heard from the wireless node, is going to set up the observe mechanism, and so it sends an observe request here. You can see this is another path, TMP for temperature, and you can see the 0 to initiate the observe. And then following that, you can see an immediate response by the wireless node, and you can see it's got the observe option in it. And initially, it's just 0 because it doesn't have the reading available to send to it yet. And here, let me just bring this up, and you can see over here. Well, you can see in the payload here. It's better back down where it was. That the value is 0. But then you can see that periodically now the wireless node is sending out the data readings. In this case, it's sending them out every 20 seconds. And here's an example of one here, and here's that 24 seconds. And so this is just going to keep on repeating, sending out these data readings for indefinitely until the server asks it to stop sending the readings. So, I know that was kind of short, but that gives you a sort of indication, and it shows you the sort of things that you can do just to help you get started trying to work with the observe mechanism and data collection, and actually also the confirmable messaging that you can see in there. And as you can see in the other slides in the presentation, there are links to where the source code is so that you can play around with this stuff yourself. So anyway, happy hacking, and we'll talk to you again. Well, I hope you found the sensor data collection application interesting and valuable. As you can see, I'm back in my orange sweater, so I'll carry on now with the rest of the slides about gcoap. So what's coming next? Right now I'm still working on the series of PRs for confirmable messaging. You can see the issue down at the bottom of the slide that talks about those various PRs. What I'm working on specifically right now is synchronous confirmable requests. And so what this is all about is that presently the requests are sent asynchronously, which means that gcoap needs to make a copy of the PDU before it sends it out, so that it just in case it needs to retry sending that message. By default, the PDU is 128 bytes, so this can get to be pretty expensive. So the idea with the synchronous confirmable messaging is to block or put the client thread to sleep while it's waiting for the response. And so that means that if the client thread is still there, its memory is still there. And so gcoap can just copy the PDU out of that memory in order to send the retry. It's a trade-off between responsiveness and memory usage, but it's definitely, I think, worth doing. So before I get on to talk about the next steps for development of gcoap, I just wanted to take a minute and talk about functional testing. This is something that's given me a lot more confidence in the implementation, and I always use it before I send off PRs just to make sure that everything is working the way it should. So gcoap does include some unit tests which do some basic testing for some of the client-server messaging, but I found that in order to really test out a number of different scenarios, it was really helpful to be able to test them live. And so in order to do that, I use pyexpect, which is a Python implementation of the expect library. And so expect allows you to send text-based character messaging from a process, and then it also allows you to listen for character-based messages, say like from standard out, coming from a process as well. And so basically what I've been able to do is to use gcoap along with libcoap and another library that I've written to use this sort of functionality. So within CoAP, I use the shell that the gcoap shell implementation that's in there to be able to do this text-based send and receive. So let me give you a little bit more specific explanation of how this works. If you haven't worked with pyexpect before, it should be clearer. So what I have here is a text editor that shows, this is just the main, so here this is the Python function that's being used for setting up one of these tests. And you can see right at the beginning here, if you can imagine what you do when you first start up RIOT, you might actually give it a make term to start up the terminal, and then you expect to get a certain response back. So in this case for gcoap, you would see back on the terminal gcoap example app. And then also you can see that in addition to using it in the tap mode for a native application, you can also use it for the shell that might be running on an actual board, in this case the SAMR21. And then you can also see this idea of being able to do the configuration for the networking. So you can carry on with this, and you can have multiple processes running, and you can see the requests and the responses going back and forth. And like I said, I found this to be very, very helpful and easy to write. And if you haven't tried it before, you might want to take a look at it. And certainly you can take a look at the tests that I've written, which are at that link that you can see here on the slide. So what's next for gcoap? Well, like everything with open source, it's what's next is what people actually implement. But I think there are some things that make sense, and then some things that I'm personally interested in that I'll mention here in this last slide. So definitely we want to see the block extension, the CoAP block extension, which allows us to send big payloads. And what I've certainly heard is that people would like to use this for doing firmware updates. So that's definitely, I think, something we want to do. Also, some sort of security, and I know that was emphasized at the RIOT Summit. So either integrating DTLS, and you can see there's a PR there that starts to work on that, and I think work on that is still ongoing, so hopefully we'll get to see that going forward. Another possibility is this application level security, the OS CoAP or OS Core, as it's called now, is another option for doing that sort of thing. For me personally, I'm very interested in network monitoring, and so an implementation of this constrained management API would be something that I'd be very interested in following up on. So I hope that gives you a good idea of what gcoap is all about, kind of where we are with the implementation, and like I said, I hope you enjoyed the demo of data collection. So just to sort of wrap up, I'd just like to say it's been a really fun ride working on gcoap, and I've lately been really happy and gratified to see the response that it's gotten from the community, from the core team accepting that, and then also from people actually starting to use it. That's what it's all about. So carry on, and hopefully I'll see you all soon on a PR or an issue or somewhere else, maybe in person one of these days. All right? Take it easy.